Hey everyone, so we are continuing with graphing in vertex form. We're going to deal with some fractions today, and then I'm also going to introduce some vocabulary that we are going to work on as well. So here is a SAT problem, so pause and try this one. So k is greater than 0. You don't really have to worry about that as much right now. X is 7. What is the value of k? So I'm going to take my equation, 2k squared plus 17, and then it says k is 7, x is 7, so minus 7 equals 0. So what do you think? We haven't done one like this, but I think we can do it. So I added the 7 to the other side, right? Now, we haven't solved a square root, but where does a square root come from? Think about when we had a square root. The opposite of a square root is a square. So we're just going to square both sides. 2k squared plus 17 equals, what's 7 squared? 49. I'm going to minus 17 on both sides. 2k squared equals 32. Divide by 2. K squared is 16. So then what's k? So remember, we put plus or minus 4, and that's why they told us greater than, because they don't want us to put negative 4. Another thing you could do, if you're having trouble and that was a lot of work, you could just plug all the numbers in, right? So the square root of 2 times 2 squared plus 17, does that equal 0? So that's the square root of 25 minus 7. That doesn't work. And then plug in 3, and then plug in 4, and then plug in 5, and see which one works. Okay, so you learned this in middle school. We talked about it a little bit in Algebra 1. So what is a function? A function is a mapping of a set of numbers. Every x maps to exactly one y. X is not allowed to map to two y's. Okay. So remember in middle school, in Algebra 1, we did the thing with we had like 1, 2, 3, A, B, C, and we mapped things, right? But you can't have two things and go to the right side, right? That's not allowed. Okay? So you're only allowed to map the 3 to one thing. All right, and those two circles are called the domain and the range, right? So the domain is the set of all x's. So when we talk about functions with equations, it's everything you can plug in. Right? The range is everything you get out. So for example, if I have y equals x plus 3, the domain, I can plug anything in I want, right? So it's all real numbers. But if I had, say I had the square root of x, the domain is not all real numbers, because what can you not have under a square root? You can't have a negative. So in this case, the domain would be x has to be greater than or equal to 0. The range is everything we get out. So when I plug in all those numbers, what are the y values that we get? So that is the range. So we're going to really kind of focus on looking at the picture to figure this out. All right, so I want you to graph this parabola, state your vertex, state your roots, and then we'll talk about the domain and range. So pause the video and graph those. So my vertex, change the sign of the inside, outside stays the same. 7 minus 4. And then we're doing our shifting rule, right? Over and up. 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 5, 6, 7, 8, 9. So there's my parabola. the roots, this thing crosses the x-axis at 5 and 9. So 5, 0, 9, 0. Okay, so now think about the domain. What am I allowed to plug in? Or is there anything I can't plug in? Can I plug in 1,000,000? Sure, it would be giant, but I could. Can I plug in -1,000,000? Can I plug in 0? Yeah. So my domain is just all real numbers. And here's the nice thing. Parabolas, it's always all real numbers. So you could just write out all real numbers, or the symbol for it is the R with a double line. Now the range is a little harder. What are the y values we have? So what's the lowest y value? My lowest y value is right here. Does this graph ever go below -4? It doesn't. So my y's have to be greater than or equal to -4. My y, because I can have 8 is right here. It can go up to 1,000,000. So you can either write it like that, y has to be greater than or equal to -4, or what I do is I do a bracket, -4, and then it's going to go up forever. Up forever just means infinity. So we're going to be including that on all of the parabolas today. All right, now we're getting a little harder with the fraction. So I want you to fill out your table. So we have our over, our up, 1, 1, 2, 4, 3, 9, 4, 16. But remember, what do we have to do with that number in front? We multiply it. So 1 times a half is a half. 4 times a half is 2. 3 times a half is 4.5. I did not leave myself enough space. 16 times a half is 8. My vertex is exactly the same. Change the sign of the inside. Outside stays the same. So I have 1, -2. So now instead of going over 1 up 1, I'm going to go over 1 up a half. Over 2 up 2. Over 3 up 4.5. 1, 2, 3. So we're just kind of estimating the best we can. And then over 4 up 8. 1, 2, 3, 4. 2, 4, 6, 8. So notice this graph, it's a little wider, right? It's not as skinny. I have my nice roots, 3 and -1. So 3, 0, -1, 0. Domain is all real numbers. Because you can plug anything into a parabola. Now write down, what do you think the range is? What's the lowest y value? My lowest y value is the vertex, -2. So y is greater than or equal to -2, or -2, comma, infinity, because it goes up forever, so it goes up to infinity. All right, next one. Try it on your own. My vertex is -4, -1, -4, -1. Now I'm going over, up, 1, 1, 2, 4, 3, 9, but it's -2, so I'm going to multiply by -2. So over 1 down 2, over 2 down 8. Uh-oh, what happens here? Where does this cross the x-axis? It doesn't. So what are the roots? They don't exist. So we're going to put NA. Remember when we did the quadratic formula and we got no real solutions? This is why. It never actually crosses the x-axis. All right, what's the domain? What are we allowed to plug in? We can plug anything in. Now this time the range is a little different. Instead of having, we don't have a lowest value. This thing goes down forever to -infinity. But what's the highest it can go? it goes up to -1. Or if you don't like writing it like that, you can say y has to be less than or equal to, this time, -1. All right, here's another one. Same process. All right, so my vertex is -7, 3. And then I'm going over 1, over and up. We have to multiply by 2. So this becomes a 2, an 8, and an 18. So over 1, up 2. And I can't even fit the 2 8. So we'll just do that. So what are my roots? My roots do not exist. If we tried to solve this like we did before in the last class, we subtract the 3, right? We divide by 2. And then we have x plus 7 squared equals this -3/2. Can we take the square root of a negative? No, and that's why we have no solution, no real solutions. So that's why we're going to put NA, no real solutions. Again, the domain is all real numbers. What is the range? What's the biggest and the smallest y value? Well, my smallest y value is right here, 3. So 3 to infinity, or y has to be greater than or equal to 3. And it's always just the y value of the vertex, right? All right, we got 2 more. Try this one on your own. This one will have roots. All right, so this one's a little tricky with the table. 1, 1, 2, 4, 3, 9, 4, 16. So I have to multiply by 1/3. All right, so 1 times 1/3 is 1/3. 4 times 1/3 is 4/3, which is 1 1/3. 9 times 1/3 is 3. And this is 16/3, which is 5 1/3. So I do the mixed numbers just to make it easier. Easier to graph. All right, so my vertex is -5, 6, and there was a negative, so we're going to go down. So we've got -5, 6. Over 1, down 1/3. Over 2, down 1 1/3. Over 3, down 3. Over 4, down 5 1/3. And then 5, if we did 5/25, that would be 8 1/3. 6, 7, 8 1/3, so like there. So we're going to have some gross number here. All right. So why don't we do the domain and the range, and then we'll talk about the roots. So our domain, all real numbers. Our range is, it's negative this time, so -infinity, because our y's are negative, up to 6, or y has to be less than or equal to 6. All right, so now we need to find the roots algebraically. So I've got 0 equals -1/3 x plus 5 squared plus 6. What do we do first? Subtract 6. All right, so now this is a little tricky. How do I get rid of this -1/3? So because it's a fraction, we're going to multiply by the reciprocal. So times 3/1, but it's got to be negative, right? So we're going to basically just multiply both sides by -3. So we get 18 equals x plus 5 squared. Now we can take the square root of both sides. So x plus 5 equals plus or minus root 18. Subtract 5. But this one is a little harder. 18 has a perfect square. Do you remember simplifying square roots? What perfect square goes into 18? 1 times 18, 2 times 9. 9 is a perfect square. So square root of 2, square root of 9, square root of 9 is 3. So my answer is negative 5 plus or minus 3 root 2. That's rough. I do understand that that's really hard. All right, last one. Try it on your own. So my vertex, I switched the order, is 8, 4. So 8, 4, 1, 2, 3, 4. I've got a negative 2, so over 1 down 2, over 2 down 8. 1, 2, 3, 4. So it's going to be a gross root again. So let's do it up here. 0 equals negative 2 x minus 8 squared plus 4. I think this one's not as bad as the last one, though. So we're going to subtract 4 on both sides. Divide by 2, the negative 2. Square root. So plus or minus root 2 equals x minus 8, and then add 8. So 8 plus or minus root 2. Oh, y-intercept. I messed these up. So our domain is all real numbers. And then what's the range? The highest value is 4, so y has to be less than or equal to 4, or negative infinity to 4. Bracket. Don't forget the number gets a bracket. And that's it.